Hello, welcome to episode 129 in this series where I am programming an NES game from scratch. I don't know why I had my headphones on still. I don't need them right now. So in the last episode, we had worked on getting the groups going so that you could actually destroy groups of enemies. And the cool thing about that was that now we have a way of tracking these things so that we can provide bonuses as we desire, and any other sorts of power-ups and things. And we had wrapped up, this was a several episode sort of thing where we were able to place these objects on the map and designate what kind of sprite they spawn, how many they spawn, and what the interval is in between spawning, and we took care of all the things like the different collisions. Obviously the collisions will need some work because they're not quite as accurate as they probably should be for a shmup, but you know, we got all the things working that we needed to. Oh, I ran out of energy. We'll need to fix some of this stuff as we go. But, you know, overall, making good progress. We're at a point where we've got sort of the major challenge, I think, with the smaller enemies done. I wanted to shift gears from this to something that I had teased to you guys on Twitter yesterday, but also something that I had shown to some folks on the Patreon, I guess a couple weeks ago now. I don't remember exactly when. But let's shift gears to the title screen. And while the title screen is not necessarily functionally important, it does have a technical ramification because of the limitations of the NES and how tile content is stored. If we look at the PPU and we look at our tiles, we can see we've got this whole title screen area loaded up in here. We have some empty tiles in here. I'm not sure I remember what those are for. Those might just be sort of remnants. We have our meta tiles here, and then we have our sprite tiles here. So Jordan put together a title screen that I really, really liked. I'll show it to you guys in a second here. But the challenge with it is the complexity of it is such that from what we were seeing, it's going to use up most of the tiles that are in here. So we have a few options available to us in terms of if we're going to try and use character RAM, or if we're going to use bank switching for the character portion of the ROM. So let's take a look at the title screen. So this is the title screen. It's sort of a mock-up of what he wanted it to look like. And there's this animation that he's got here. You can see in the middle of this sort of really cool shimmer. I really, really like the way that looks. And then this sort of bouncy motion on the text. We weren't 100% sure about whether or not that would stay. I like the idea of it, but you know, I mean, for now, it's we can play around with that. I like the font that he also used for this. I think it looks really good. I think it looks really excellent. That's got the consistent stripe of color through it. And then we could, change the color of the main portion of the text pretty easily to reuse in other parts of the game where the light blue might not be appropriate. So yeah, so like I'm pretty happy with the way that this looks, and you know, I don't know that it's the final, but I think that's pretty awesome. And he spent a lot of time not only building this, but also figuring out how this was going to be assembled for the NES. So he divided it up into two parts. There's this part, which is the background layer, and then there's this part, which is the sprite layer. And we need to figure out exactly how that's all going to fit together in code. But one thing that I did was I had passed along to him this tool that was written by Kasumi. It's called ICHR, and what you can do is you can export your frames of animation and your images and use it to, here we'll do it right on the fly. Hopefully this will work the way I want it to. You drag that in and it will analyze the content and turn it into, if possible, an NES ready tile set and animation. And so you can sort of see what's going on here. It's got the little shimmer animation. It's got the tile set here that it's created. And it gives you statistics about what it's done. So there are 239 tiles, 16 colors, no errors, which is good. And then you can mess with the frame delay. You can increase it or decrease it. It's a little hard to see here because of the because of how small everything is. So what's cool is that after you get this done, right, and you have all this here, it actually generates a, let's go to, there's a button, there's a key you can press. Let's see, where is it? Yeah, so if you change the delay in the frames, like let's say I want this to be faster, then you press R, it will reprocess and regenerate a ROM file, and then you can open that up in any emulator and you can see what that looks like. So that's a little too fast. Let's go back to this, and you can see that now it's a little bit slower. And I mean, the other great thing about the way that this works is that, you know, this ROM is totally just something you can load up on something like an EverDrive and play in an original NES or your AVS or whatever. It's totally compatible. So I was able to see what that looked like. And again, it's not the full title screen because it's missing some of the components due to the sprite layer not being there. Let's see if we can do a side-by-side here. I mean, and that's not the fault of the tool. We're going to have to export that out separately. We can even do that here tonight. I haven't tried that, so I have no idea what it's going to do. It'll be an interesting experiment. But if we put them side by side, you can see the colors are a little different. These are the best approximations based on the NES color palette. And it's missing, obviously, the text bounce, which isn't something that we would want to include in. We would want to just stick to this because the menu is something that we would render in real time, or put into the tile. Well, maybe I don't know. I don't know how exactly we would do that, but it's you can see this looks pretty close to what's being done here in ASprite. And if we look at the PPU, we can see in the char viewer that it is the same two. So okay, so yeah, the two tile set views are fully populated with the tiles on the for the background here. Curious, what is this doing that it's... Is this... I didn't actually look to see what mapper this is using. Mapper 4. Mapper 4. I am still working on that mapper tool that I was talking about in one of the previous episodes, which will allow you to search for mappers based on your requirements. I haven't had a chance to look at it much, but I will be making it available online soon, by hopefully the end of this week, with whatever mappers I'm able to get in there. So I'll be sure to post that here on Twitter and on the YouTube channel and stuff like that. So is this just bank switching? Looks like it's just bank switching. Let's see. PPU. 2K switchable, 2K switchable, 1K switchable, 1K. So how is it doing that? Select 2K, char bank at PPU. So these value specify which bank register to update on next write to bank data. Specify which bank register to update on next write to bank data register. Bank data. New bank value based on the last. So what you would do is you would write which of these banks you want to update, either the prog-rom or the char-rom, and then you'd write to this bank data at 8001 or somewhere thereabouts, and write which bank you want it to use. So 8000 and 8001. Let's see if Kasumi is just doing that directly on those registers. Probably. Let's see. Store Y 8000 and then store A in 8001. So load Y82, store in 8000. So 82 would get us that we want to update this 1K at 1000. That is, or 0 to 3FF. Let's Let's see if we can figure this out, because we do need to know how this is working to figure out if this is what we're going to do. Because I'm not sure if I want to use MMC3 still, given that we're not using the horizontal line counter anymore. So let's see. Increment 40, load 5D, branch plus 2, EO7B. EO7B is this. Okay, so we're skipping load A0, store A into 5D. Oh, I guess this is just a counter that we're using. Load Y 82, load X 0. So let's see, so 82, that would be character A12 inversion, two banks at 1000 to 1FF, and 4 1K banks at 0 to 0FFF. 0FFF is here-ish. So we're saying there are 4 1K banks here, I guess, and then 2 2K banks here. And then let's see, and then the 2 is select 1K character bank at 0 to 3FFF, which would be, let's see, 0 to 3FFF, so somewhere over here. I mean, if there are four of these guys here, we can even, let's will this work? If I do this? No. So if there are 4 of these guys here, then what we're talking about is something like, how many of these do we have? 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. 1, 2, 3. Okay, I thought so. So there'd be four rows. So it's a bad color to do what I want to do. So it's dividing it up thusly, right? So here's, oh, except I was off in my partitioning. There we go. Yeah. So this would be 1. This is 2. This is 3. That's 4. Right? So what we're saying is we're changing the value of 0 to 03FF, which is this first section. And what are we changing it to? Load X0. So store Y in 8000. Load A. Let's see. Is that 0? We're saying load that with a 0, and then we're updating this to be 0, and then we're incrementing y and x. It's interesting. So we're just sequentially setting this. Seems that way. Seems like it's just sequentially setting it. Let's take a look at this in YYCHR, because I want to see. And this is probably going to be the focus of just like us trying to figure this out tonight. It's going to be probably not so much coding as just trying to understand this and then kind of mess with this a little bit. All right, so what am I looking at here? No, what are you doing? So I'm trying to figure out, let's do this. Let's start with, if we look at this, let's open that in. I need to sort of orient my my thinking a little bit to make sense of how this is unpacking it. So, all right, so this is the whole thing across. And then if you look then further down, we have our sprite data. Okay. So that makes sense. So then if we go back to this, and we reopen this, that's this part. And then is it just a bunch of it? Yeah, it looks like it is. So it looks like once we get past this end here, the next thing we do is we load another 4-row set and then another 4-row set. How many are there? So going back to the beginning, there's 1 bank, 2, 3. So there's 3 other banks that it's switching between to create this little shimmery effect, which is kind of, if you think about it, it's a little bit wasteful because it's swapping out this whole thing here to create that effect, right? That whole, if I'm right, that's a 1K section. Oh, and you can actually see, that's funny. So you can see it changing as the emulator is swapping the banks. That's a nice little feature so you can see what it's doing. Oh, I see. So is that... No. I thought maybe this was... Never mind. Okay. So it's swapping the banks. How is it doing that, though? Because... the only part that needs to change is this last bank here. Store by 8,000. Load 4DX. I assume that value is not the same every time. Yeah, so you can see if you watch A as I hit F5 to continue, that value is changing and it's swapping the banks. And it's hard to tell because the only thing that changes is that sort of sparkle area. So you can see it just changed if you watch that carefully. But that gives that animation. So then the next question is, okay, what's at 4D that has that information about the counter? So this is the start of the program, it looks like. Maybe. No. Let's see, where is 4D being modified? Or is there data? Maybe there's data stored somewhere in the ROM. So 4D. 4D 0, 1, 2, 6. So this is getting updated. Add watch. Oh. Oh, not watch. I want a breakpoint. Right. Okay. So if we run, get rid of that. Load X0, store X into 4D, increment X 4E into 50. But why? E014. Add carry E014. So it's adding 1. It's E015. The number, the delay, the number of frames of delay, potentially. Looks like it. It looks like it's maybe doing some sort of counter. 5C. See if that's right. Looks like it. So 5C is being incremented, and once it hits 7, we're incrementing this value, which is then used to determine which bank we want to swap in for the title screen animation. Now this doesn't include, like I said before, the sprites that we're trying to use as well. Let's get rid of this breakpoint. And that's going to be a little bit trickier because, let's stop this animation for a second. If we turn off everything for a second. So if we take a look at this, there's only a little bit of stuff that actually has to fit into the sprites. So let's, if we export this, where did I put this stuff? I put it in the desktop. because that's where all important files are supposed to go. Didn't you know that? So, title 1 sprites.png, and we'll see what it says when we try to export that. Yeah, it can export the 4 as an animation, but I don't actually think it was doing any animation between those. Could be wrong, but I'm pretty sure. Pretty sure that it is not. So the cool thing is we should be able to just pop that into here, and it should tell us, oh, it is? Interesting. Interesting. So so the sprite layer is doing animation as well as the backgrounds. So combining this should be interesting. I always wonder if it's necessary to do, because let's just open this up, and do I have FCEUX on here still? Taco. If we look at this for a second, it's that's 4x. Can we make this 4x also and have it miraculously why aren't you letting me do that? So this is 4x. Is that what you're saying? Close enough? Let's say it's close enough for now. So I see. So this would improve the animation over here a little bit, because right now it's a little sparser. Okay, yeah, it's a little more sparse than the actual animation here, which has some of the darker color that's missing from the background only one. So here's the question, right? Like, do we... And I don't think I can answer this right now. I think I need to do some more research. So I'm going to just state this right now, that I don't think I can... Well, I don't want it to say that. Let's just plow forward a little bit. Sorry. What I was going to say is I'm not sure I can actually implement this right now without doing some more research, but that may be true, that may not be true. I'm not 100% sure. Let's just keep investigating this. Also noticed that there's a little flicker of animation here, which is interesting. It's not supposed to do that. Oh, it's just it's an artifact in the actual graphics. That one pixel got moved. Which way do I like it better? I think I like it there better. So let's fix that. Oops. Let's fix that one. Okay. No point in introducing animations that don't need to be there. So let's re-export that. See if this did it just, yep. So let's re-export that. Removed one frame. See, the thing is, I'm not 100% sure or removed one tile, not one frame. I'm not 100% sure if it makes more sense to do this with bank switching or character RAM. The thing that I keep going back to for character RAM is the following. While there is more time required to load tiles into the RAM, you get the flexibility of being able to do things like when we start the game, we load all these tiles plus the additional smaller subset of animation tiles, not the whole bank of 4 rows of tiles. And same thing goes for the sprite layer, which would be down here at the bottom. We could load those into, well, actually, we could even be smarter than that potentially. Depending on how much content we actually have to change in every cycle for the title screen, we could do something where try this one more time. No. Doesn't like pasting from when you do a print screen. Okay. Well, congratulations, Paint. You've officially done something better than a more capable drawing program. There we go. So what we could do is just simply under the covers, because we'd have to change only the tiles that need changing, we could potentially get away with just updating the character RAM for the tiles that correspond to what's in the title screen. So like these tiles here that do the little shimmering effect, you could just update those in the character RAM directly. Instead of any sort of bank switching. And then when we're done with the title screen, going back to the PPU viewer, when it's time to load level 1, we load level 1 starting at tile 1 over here. And all of our tiles can populate here, same thing with sprites. Then when we go to create level 2, same thing, we can start from tile 1 and move forward. And we have the ability to always have the offset be from 1. And there's something definitely appealing about that from the perspective of not having to know the offsets of the previous level tile counts to know where these tile sets live. And then we don't have to worry about how the other levels actually function. They can more or less be standalone. We would obviously have a way of knowing when meta tiles are reused, because we don't want to duplicate the meta tiles, but when they're thrown into the maps, we're just able to load them into a position that's comfortable for drawing the map on the screen in the name table here, rather than having to kind of find them in this and do bank switching as we run out of space for the levels to live within our character sets. So I'm thinking that's what I want to do. I really do think that that's going to save us a lot of headaches. And then will allow us to do the animations more easily, because we won't have to change the, that's what I was trying to say before. So instead of having to change trying to change the name table by updating these tiles, we wouldn't do that, because that's not super efficient. We can update the content of just these this row of data in the character RAM. Let's take a quick look at how we would go around, how we'd go about setting up our game for character RAM. that's going to break some things. We're going to have to change our code to, at least in the beginning, load up the tiles the same way they were loaded before. But let's just start with, if we can break it and load some data into one of the tiles to prove that we know how to do this. We'll call it a night, and Thursday we'll pick up from there and try to load the entire character set and even potentially get the title screen drawing. So hopefully you guys like this too. I think this turned out awesome. I think Jordan did a great job. Obviously, since I've said that a ton of times already, but all right. So we're using MMC3. So in the INES header, we now need to specify that we're using RAM. Don't ask me how, because I don't know how. But we'll figure it out. Map is a stripper with character RAM. Is it down to the mapper? It could be. I really don't know. I know that mapper 34 is GT, no, BN ROM, and that has 8K of RAM. This says 120. It has 128K of max of ROM size with a 32K ROM window. We could try switching and see how badly that breaks our code. Where does the code start? I think it'll be okay. Well, let's just give this a try. So going back to INES for a second. Flags 6, mirroring. Where is our mapper? Flags 6. Cartridge. Oh, the low nibble of the mapper number. So if it's 34, that's decimal 34. It's 22. So is that right? MMC3 was 1, 2, 4. It was 4. I don't remember. I assume that that's right, but I mean, we're obviously using MMC3, but I don't remember if it's just 4. It is. Okay. So this becomes 2, that nibble, because it's 22 in hex. So then we need to put a 2 in the next nibble up in flag 7. But it's in this 4 bits here, so it's going to be 2, 0 here. We can just make this hex 21. Alright, let's see how badly we broke this now. I assume that we're not going to see anything in the game, but... Oh, I loaded the wrong thing. Okay. So far, it's not worse than I thought it was going to be. It looks like the code actually executed correctly, so that's good to see, because I wasn't 100% sure on that one. Okay, cool. So we've got this. The problem is right now the character, you know, the ROM, the character content is garbage. So what we need to do is we need to update. Let's update tile 0. Let's make it solid black. All right. Now the way that we're going to do that, if I recall correctly, is there is, just like you upload any data to the PPU through the combination of 4006 and 4007. Why do I not? Have that, or is it not 4000? What is it? That sounded right in my head, but 2006 and 2007? 2006, 2007. Sorry, yes. 2006 and 2007. So 2006 will set the address of the PPU that we want to update. And 2007 will be where we write the data. And so we will start by writing the data for a blank tile, which should be easy because it should just all be 0. Let's just double check. There's an example code here. All right, and so the memory starts at PPU address 0. So let's just start with that. I think this is no longer necessary because we're not using MMC3 anymore. This is also not necessary because we're not using MMC3 anymore. But let's load A, 0, store A, 2006, and then do it again because we are storing the address as 2 bytes, obviously. And then we want to store A 2007, and then we can keep doing this. Let's just really basic here. Let's repeat that. Let me think about this for a second. So how many bytes is it for a tile? Is it just 16 bytes? Or is it 8? It's 16. Okay, so we'll do 16 repeat stores into 2007, hex 2007, and if we rebuild and restart the game, hopefully we'll get a blank tile there now. I don't know, but we'll... No? Let's see. Come on. Can't go to the top. Load A, store A, 2006, 2006, store A, 2007. I mean, that should do it, probably, maybe. Obviously not. Okay. Load, store a source, source plus 1. Load Y, 0, store Y, PPU adder, store Y, PPU adder, load A, store A, PPU data. Number of 256 byte pages to copy. Is it doing anything? Tile address is 0. PPU address is 0. Do I have to make sure the PPU mask is off? I don't think it's drawing anything. I think we hadn't gotten anything set up for that yet, so we had cleared the memory. Oh, maybe we're too early for doing that yet, because we didn't wait for the VBlank the first time there. Initialize audio, store a game state, sprite mem. So that's the second VBlank. So let's see if that helps anything, because if the PPU isn't ready, I guess it wouldn't store that info, possibly. Let's take a quick look. Got way too many of those open. Let me take a look at the memory and the PPU. So that is all 0. Oh, and this one crashed. Not something that happens too often, but it happened this time. PPU memory, so it is... Oh, it doesn't like that, huh? If I pause it. No? Is there an update? It's the latest version. Okay. Well, I can't look at the memory directly, but I mean, definitely seems like it's not updating it correctly. So I'm sure I'm just missing something ridiculous here. Oh, yeah. I didn't do this. You gotta change your character ROM banks to 0. Stop it. Right, so now we have a different problem, which is we have nothing. Nothing. And we have nothing. Which is fine, except that I want to actually see that we updated the tiles, so let's change the value to 1 and make sure that we actually get a solid tile as that first tile. Okay, so we got something. Oh, but it can't be 1, dummy. If it's 1. It's got to be, if it's got to be set to some sort of value, it can't just be 1. All right, so now we've set that to, what is that even? Does it tell me? I can update it, but click on the tile to draw the selected color. Right click draws background color. It'd be nice if it said what the color here was. Okay, so it's probably this. It's probably 3. Thinking about it, if we wanted it to be 1. That's close. Let's do it in binary because it's got to be like that. Which is, what is that? That's 10 and 10 A. That's close. That's not what exactly what I wanted. It's that weird bit pattern thing that you got to do in order to make this work properly. Let's go back to YYCHR for a second. If I remember, it's something like that, isn't it? I won't spend too much time guessing here. It's not really important for what we're trying to do. That gets us that pattern. Can I change it to the blinking one? I got to read up on the format of the tiles again because I don't remember exactly how that works anymore. It's been a while since I wrote the code that handles how that's stored. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay, so it's more of a. So if that's the case, yeah. So the problem is we're repeating the same value over and over again. So what we could do is if I wanted to do something like I want it to have the first line blink, I could do FF and store that, and then store 7 more of 0, and then same thing. And, oh, not FF. Let's see, 2 is that the second pattern thing is filled. So let's just do 8 of this, and then 7 of that. But let's see, load A, FF that one, store it, and then load A. Okay. Let's see if that does what I think it'll do. Which, yes, okay, cool. So we made this tile have the blinking color in it. Now we can, if we wanted to, we could model the tiles however we wanted. You can see it's filling in. Anyway, so the point is that the character RAM is working, and now what we would need to do is say, okay, we've got this stuff here in the character ROM area. That goes away. And instead, you can do it right here, I guess, and say, do something like that. So now the problem is that our bank overflowed, and let's see, so if we go back to the mappers, where are you, mappers? Go to 34. The program size is 128 kilobytes with 32. Bank size is 32K, right? So how many? What is that? That's 4. It's 4. 4 program banks, but the IMAP header, or the INES header, I mean, not IMAP, where it says the number of program, size of program is 16K. We need more of that, so let's say we have 64K. That's 4. That's what I thought. Okay. And then we need to fix our configuration for CC65 because the NES configuration says that it's different. So the area ROM 3. Let's see, how big is the window? I shouldn't keep closing. 34. So the window, the program bank size is 32K, which is what? Is that 4,000 hex? 8,000x. So and then that would imply that there's really only one of these guys. Do we define ROM 0? We define these all over here. So we just have ROM 0, it's 32K, and ROM 1, where so let's do everything in code A. Let's see if this breaks. All right, that rebuilt. It's exciting. I thought that was going to be broken for sure. like the ROM. Could not load file. Interesting. Why? Let's see. So we said it's 64K. The configuration says code A is ROM 0. ROM 0 starts at 8,000. And the size is 64K. Oh wait, 64K. We can't do that because yeah, you can't do that. The bank is only 32. Poop. So then this is our second bank, and that's also 32K. Is 32K too big for this? I think it is, probably, isn't it? I'm doing that in decimal. No, this goes to C0. So, in theory, that should be okay. That's 32K, right? No, that's only 16K. Sorry. I'm confusing myself here because I'm getting tired. So there are two banks now of 32K. The mapper supports 32K bank size, 128K. Select 32 bank. What does it do by default? I assume. Oh, 8,000 is the register. So I can't start there. Where do I start my... Okay, so that explains a little bit. 8,000 won't work because that is where the register lives. So the memory map for ROMs, 4020. If we start at... we go too far. How... So this is, I guess... I'm not exactly sure. What's confusing is, or not confusing, what's not helpful is that it will not load the ROM. Oh, it did load it this time. Debugger. Okay. Let's restart the code. Okay, so it doesn't look like it's actually resetting to the reset on the instruction. Where's IPC at? Where's my program counter? PC is 0. Oh, wait a minute. Did I... Segment vectors. Well, it's still there. That's ROM V. And ROM V starts at FFFA. So that's still all where it's supposed to be. That's garbage. That's not needed anymore because we don't have NES config. What? Oh. So it's saying that it's starting the code. That's so weird. Okay. I mean, I'm not sure what I expected, to be honest with you, because we haven't made a drastic change like this before. So what I'm thinking is happening, let's do this. Let's change, well, if the register is at 8,000, if the register is at 8,000, then writing to it is going to be a weird situation, but reading, let's take a look. So this is what I guess I was reading about when it comes to bus conflicts. Because there's an overlap with the register and the ROM. So all of those work for writing as the register. Okay. Sure that all devices in the bus are asserting the same value by writing to a ROM location that already contains the value that you are writing. For instance, to switch to bank 5, write a 5 to the ROM location to a ROM location that already contains 5. Well, so but we're not, that's fine, I guess, but that's not, we're not even doing that yet. We're just getting started. Surprised. I thought. Okay, so some of these mappers have this here. But I guess all banks are fixed. It doesn't really say where the banks start. Do I have any games that I think that says this is a IREM mapper? Is what that implies, that little icon. I have this, let's see, debug, tools, options, debug. Is this 34? This is mapper 4, it's MMC3. I don't know. Deadly Towers. Dark Seed. have to look up. I don't know why it doesn't supply. I guess it just based on the fact that the prog-rom bank size is 32K, it doesn't really matter, or maybe it does, but it doesn't seem to. There's no recommended location to start. Let's take a look at just for a second, and then we're going to wrap here because I'm going to need to do some more research. I want to see what this is generating in terms of addresses. So like reset, address size, absolute, scope, 0def ref, value 836C. So it is getting that value. Let's load the ROM up for a second, one more second. Let's take a look at the memory where the vectors are supposed to be. And, well, that's fun. Let's take a look at where, so I wonder if the problem, that would make sense. I think the problem is that our vector code is probably only in one of the banks and not both. And that is going to cause a problem because depending on what the mapper does, we won't know what bank we're in. So the vectors always start at that address. Let me think about it this way for a second. If we're starting at 8,000, maybe that's the problem. If we're starting at 8,000, we're adding 8,000. We're going up to FFFF, which is the last possible for the ROM. So how it is in CA65, can we do something like the org? CA65 documentation. We need to put so let's, instead of doing this, let's do org, and what is the address that I set this up for? FFFA. So in that ROM bank, we have that. And then what we're going to do is we're going to do segment code B, and we're going to have something called reset B here, and that is going to load a 0, store A into 8,000 to force the bank switch. Right, we want to say we want to be in prog-rom bank 0, and then we're going to jump to reset. Actually, yeah, we're going to jump to reset, which that address should still be okay. And then same thing here, org FFFA and word 0 word reset B and word 0. Because we're here, the only thing we care about is if we're in that portion of the code, String constant expected 1930. Oh, if we're in that segment of the code, we want to reset the game to jump on reset. We want it to set the bank properly and then actually go to the reset. 1939. What? Code B, NES config, 8000, size 8000, fill yes, shooter, segment code B, reset B is here, jump to reset, org FFFA, word 0, word that, what's 1939. Error, range error, 65536, not in. Well, it doesn't matter. You don't. I'm confused. That address shouldn't be at 6,000. Oh, sorry, 8,000. Reset 2 or reset B. It's not, it didn't generate it yet, I guess. Okay. Let's cheat and try hard coding the address to 8,000 like that. Segment vectors does not exist. That's okay. Vectors don't need that anymore. Missing memory, code B. Oh, maybe that's why. That could be why it didn't know what to do, because code B was not defined anywhere. Let's see. No. Alright. So if we go back to this for a second, reset B, the value is that. But that doesn't make any sense because ROM 0, ROM... Can I change that to this? Would that fix that? I mean, it should be. It should be allowing these to overlap, saying that they're both starting at 8,000. I mean, that explains why the assembler is complaining about this address, right? This should be 8,000. Well, you know what? Let's see what it does, because it's not right, but maybe this will at least run right, and then we can figure out why the assembler hates it. Let's go to our code here. What's let's look at where reset. Let's see, 8,000 is here. And then reset B. That's interesting that it's over here. And then this is totally ignored. Why would that be? Segment code A. You'd think that it would actually do what that says to do. Code B is load ROM 1 or ROM 0, which starts at 8,000. I mean, we could even try. But the thing is, it's ignoring that org also, because start a section of absolute code. The command is followed by a constant expression that gives the PC counter a location. Use relock. Switch back to relocatable code. By default, absolute is global. Using the feature org per seg can be made segment local. This feature makes relocatable absolute mode local to the current segment. So basically, am I forced to do this then? No, I don't think so. I feel like that's going to be a problem. Yeah. So placing code a specific address is the job of the linker, not the assembler, so there is no reason to. Fine. Okay, so are we saying that this should be segment vector? I mean, and then vectors 2 or vectors B for argument's sake. I'm just trying to understand what I'm doing wrong here. Okay, but why? Why does it overflow? Because it should just be areas by 6 bytes. Overflows ROM V. Do I need to do something like that? I mean, this is a little weird, but so then I guess it's keeping track of how these things are. Oh, okay. That seems to have worked now. We had 8,000 as the address, so that's good. It's weird. It's still not. Let's go to the memory and see what's in. See what's at the end. Nothing. Let's see something here. Reset B. Okay, it's not complaining about that anymore, so that's good, but it's also not getting an address here. Like that should be that. Not 0. So I'm not sure why that would happen. Let's see, vectors B. Starts in the same place. Does it matter? It's kind of random, but does that matter? I don't know why it would, but it could potentially, I guess. No. All right. I'm going to wrap for tonight. I went longer than I wanted to. Made some good progress in terms of getting the mapper stuff at least set up. I got to research some more of how to fix this stuff, but as always, thank you for watching. If you'd like to ask me any questions or say hi or any of those sorts of things, feel free to reach out to me on Twitter at Clairvis. I am on Nintendo Age as Zelius. You can reach me by my email. Why is this? Oh, yeah, it did load it properly. Feel free to add comments and questions on the video recording on YouTube. Try to get back to those as quickly as possible. There's also a Buy Me a Coffee link and a link to the Patreon if you're interested in supporting this crazy endeavor that I'm doing. On the Patreon, I tend to post longer write-ups about what was done here and things that might have not gone as smoothly as I wanted and things that went better than expected, and basically just kind of me freeform writing about what it is we did. But anyway, thanks again for watching, and I'll see you Thursday for the live stream. Have a good night. Take care. Bye.